The third conic section, the fourth conic section actually we talked about in the beginning, are hyperbolas. And so here, section 9.3, the objectives are to graph the standard form of the equation of a hyperbola. And there's also a non-standard form of the hyperbola. We're going to look at how to graph that. So a hyperbola looks like a pair of parabolas, but the actual shapes are different. And one of them is that the hyperbola has two vertices. And the line through the vertices is known as an axis. And the point halfway between the vertices is called the center. So and here's what it looks like when we cut a cone in this fashion here, parallel to the side, then we get a parabola. But when we cut it coaxial or in parallel to the vertical axis, then we get the hyperbola, the two branches of hyperbola, and with a vertex here and there. And so in a plane, a hyperbola has two branches, this one and that one, and it has vertices, and it has a center. Now notice that the center is outside the hyperbola. So here you have a hyperbola in 3 dimensions, and here you have a hyperbola in a plane, or in 2 dimensions. So here are the equations of hyperbolas. And so hyperbolas with their centers at the origin have equations as follows. When the x-axis is horizontal, then x squared divided by a squared minus y squared divided by b squared equals 1. And when the axis is vertical, then it's y squared divided by b squared minus x squared divided by a squared equals 1. So notice that for the horizontal axis versus the vertical axis, these terms are interchanged. Now there's something new that's called the asymptotes of a hyperbola. So for hyperbolas with equations as given above, the asymptotes are lines y equals b divided by a times x and y equals minus b divided by a times x. These are straight lines, and as the hyperbola is centered at the origin, then of course the lines go through the origin, since the y-intercept is equal to 0 for these equations for y. And so graphically, here's what it looks like. So the first case, x squared divided by a squared minus y squared divided by b squared equals 1. We have the axis horizontal, and then the asymptotes are y equals b divided by a times x, and minus b divided by a times x. So these are the two asymptotes. And what's happening here is that the hyperbolas, or that the hyperbola with branches, approach the asymptotes as x gets smaller and as x gets larger, but they never reach the asymptotes directly. So they don't cross over, they don't connect. Now when the axis is horizontal, we have the equation y squared divided by b squared minus x squared divided by a squared equals 1. And again, we have the equations for the asymptotes, y equals b divided by a times x, and y equals minus b divided by a times x. Again, these are the asymptotes for these branches of the hyperbola. These are good examples to memorize and to see how these terms relate, how the equations relate to the graph and the asymptotes. So now first assignment, we are supposed to graph the hyperbola given by x squared divided by 16 minus y squared divided by 25 equals 1. So we can rewrite that as x squared divided by 4 squared minus y squared divided by 5 squared. In other words, a equals 4 and b equals 5. So the asymptotes are y equals 5 divided by 4 times x and minus 5 divided by 4 times x. So the hyperbola is horizontal because b is greater than a or a is less than b. So then the x-intercepts are minus 4 and 0 and 4 and 0. So we sketch the asymptotes, plot the intercepts, and draw the hyperbola. So here we graphed the asymptotes, y equals minus 5/4 x and y equals 5/4 x. And it's always a good idea to draw them first because that'll give you an idea how to graph the parabolas. And here are the x-intercepts, 4, 0 and minus 4, 0, and then with a kind of a rounded shape here. And so that is the graph of x squared divided by 16 minus y squared divided by 25 equals 1. So it's fairly straightforward. For the next exercise, we have to graph y squared divided by 9 minus x squared divided by 49 equals 1. So we can rewrite this as y squared divided by 3 squared minus x squared divided by 7 squared equals 1. So here we have the y-intercept at 0, minus 3 and 0, 3. It's a vertical hyperbola, and then the asymptote, the equations for the asymptotes are y equals 7/3 x and y equals minus 7/3 x. So we graph the intercepts, the y-intercepts, and the asymptotes. And here is a graph of the equation y squared divided by 9 minus x squared divided by 49 equals 1. Next, we have to graph x squared divided by 49 minus y squared divided by 9 equals 1. So we can rewrite this as x squared divided by 7 squared minus y squared divided by 3 squared equals 1. So it means a is equal to 7 and b is equal to 3. It's a horizontal hyperbola. And the x-intercepts, so the x-intercepts minus 7, 0 and 7, 0. So here we have identified this as a horizontal hyperbola with x-intercepts minus 7, 0 and 7, 0. And the asymptotes have the equations y equals 37x and y equals minus 37x. So here are the asymptotes, and here are the vertices, the x-intercepts. And of course, here's the center at the origin. And here are the here's a graph of x squared divided by 49 minus y squared divided by 9 equals 1. Here's a slight correction to the previous problem. B is equal to 3 and A is equal to 7. And then the asymptotes have equations y equals 37x and y equals minus 37x. And so here are the asymptotes with the given equations. All of the equations we've examined for the hyperbolas are in standard form. But there are other hyperbolas, and one of them is this. Hyperbolas having the x and y axis as asymptotes, in other words, the vertical and horizontal axes as asymptotes, have equations as follows. Y times x equals c, where c is the non-zero constant. And to explain this, we will look at an example. So to graph this equation, we make a simple table of values. We pick some values for x, use the corresponding values for y, and have our ordered pairs. And as we plot these ordered pairs, we get the graph of the equation. So this is a graph of the equation x times y equals 8, with the x-axis and the y-axis as asymptotes. Also, I recommend, for checking your level of understanding, go to page 745 and match each equation with its graph. By doing that, you get a pretty good understanding which equations and which graphs correlate, and so I highly recommend that. And this concludes section 9.3. So this is the end of section 9.3, and this is the end of chapter 9.